Okay, so today we're on 102B11, which we're starting chemistry this week. So this is where we're gonna go over all the properties of matter today. So let me go ahead and share my screen with you. Okay. So we're gonna go over properties of matter. Can y'all see that? Thumbs up, thumbs down, something? Can we see it? Okay, good. Properties of matter, physical and chemical changes, elements and chemical bonds. So why do you need to know chemistry? Because every product that you use has chemistry involved with it. So some chemicals are a little bit stronger than others. Like a hair relaxer, right? It's going to be a little bit more stronger than a gel, but it all has some type of chemicals behind it on how it's made, some type of chemistry on how it's made. So let's see, 5 elements, chemical structure. Okay, so we start with matter. You guys remember when they dropped Mentos into a bottle of soda? Anyone ever did that science experiment where you drop Mentos into like a 2-liter bottle and it just shot up like a geyser? It exploded everywhere. By the way, of all the sodas that I tried that with, Diet Coke gave you the highest geyser that it held with it. But it's all chemistry, right? So there are some surprises that happen with that. So yeah, chemistry does hold some surprises there with the especially. That was fun. We should do that. You have to run really fast though, so you don't get sprayed with soda. Okay, so the definition of chemistry is physical of matter. So if you see that, what is the scientific study of matter and the physical and chemical changes of matter? You're going to know that that is chemistry because that's the definition. Okay, so what is matter? So matter is anything that occupies space and has a weight. Anything that, occupies space and has weight. Air is matter. The chair that you're sitting in right now is matter. You are matter. Anything that occupies space and has a weight to it. A gas is a matter. Anything is, just about anything is matter. Okay. So what is matter to us? Well, it is hair, skin, nails, water, oxygen, products that we use, like everything. When they talk about chemistry, there's 2 types of chemistry that we deal with. We have organic chemistry and inorganic chemistry. So organic chemistry deals with anything that was alive or is alive. Okay, inorganic chemistry is anything that has not been alive or will never be alive. So the difference in that is carbon. The element carbon is present in organic chemistry. That's how come, like, when they get old bones, they can do carbon dating to kind of figure out just how old these bones might be because that was once alive. And carbon is the element that it makes the difference between the organic and the inorganic chemistry. So inorganic things are like rocks and minerals and water, things that are not alive or will never be alive. That's inorganic. Inorganic is things that are alive. And remember, matter is anything that occupies space and has weight. So in order for it to be matter, there's these 5 things that they have to have, which are the properties of matter. Okay, color, odor, density or weight, the melting or boiling point, and the hardness, softness, or glossiness that makes it that substance. Those are the 5 things that make it matter. Without that, then it's not matter. It's not anything that occupies space. Okay, so those are the 5 things that we have to have. So then there's these basic forms of matter, and this is how basic they come: in a solid, a liquid, or a gas. Okay. So what do you need to know about these? Well, you need to know if it has weight, if it has volume, or if it has shape. Okay, so a solid has weight, volume, and shape. A liquid has weight and volume, but no shape. Okay. And a gas has weight, but no shape or no volume. Okay. So when we look at this, for an example, hair is a solid, right? A piece of hair is solid because it definitely has weight, volume, and shape. Conditioners, perm solutions, gels, most of these are sort of liquidy. Okay, they have weight and volume, but they have no shape. That's why they have to be in a container to hold them. Oxygen is a colorless and odorless gas. It has weight, even though it doesn't seem to have shape or volume, it does have weight. So those are the 3 basic forms that they come in, and you're going to have to know which one has weight and volume and shape. So now we have these physical and chemical changes of matter. They can be changed in 1 or 2 ways, which would be a chemical change or a physical change. So a definition of a physical change is changing the physical characteristics of a substance without creating a new substance. So they're showing water to ice. Okay, ice is still water. It's just changed the physical appearance of it, right? So or ice melting from being frozen to water. It's still water. Any way you look at it, it is still water. Okay, let's see. Crushing a can, mixing sand and water, breaking a glass or shredding a paper still is the same stuff. It's just changing the form of it. Okay, so that's a physical change. We get down to a chemical change. And a chemical change occurs when hydrogen combines with oxygen to create a new substance. That's an example. A chemical change there. Water and carbon make, hydrogen and oxygen make water. Okay, so that's what they're saying, H2O, right? Water. But a chemical change is a substance that creates a new substance with chemical characteristics different from those of the original substance. So iron can turn to rust. Okay, now it's rusted, it's not iron anymore. We have the water example. Another example could be when we put permanent hair color on hair, or when we straighten hair, or when we chemically perm hair. All of that is making a chemical change within your hair with these chemicals. Okay, so elements. This question gets missed so many times on a test when they ask you, what is a pure substance that cannot be broken down into simpler substances? It is an element. An element cannot be broken down. Okay, so all matter, whether it's solid, liquid, or gas, whether living or non-living, consists of atoms. Okay, atoms make it all up. These atoms make up elements, which are basic pure substances that cannot be broken down. So our hair is made up of elements, right? We have 2 solids, carbon and sulfur, and 3 gases, hydrogen, nitrogen, and oxygen, that make this acronym spelled CHONS: carbon, oxygen, hydrogen, nitrogen, and sulfur. This is what our hair is made out of. Those are the elements that our hair is made of. So we have our sulfur. This is why we're perming and relaxing the sulfur bonds, the disulfide bonds. This is what they work on. So remember that cones, COHNS. That's going to help you remember what your hair is made out of. There's those 5 elements that are real important to us: carbon, hydrogen, carbon, nitrogen, oxygen, sulfur. But just remember it as being CHONS, and that will help you remember a little bit better on how these elements work. But remember, elements cannot be broken down into simpler substances, and those are the ones that are important to us. There's our acronym right there. COHNS. That's the elements found in our hair. So there's 118 elements. Those above the 92nd element are synthetic and do not occur naturally. So just remember, we have the basics of our hair nails as carbon, oxygen, hydrogen, nitrogen, and sulfur. And there's a lot more elements out there, but those are the ones that are important to us. Okay, so then we go to atoms. Atoms are the smallest unit of an element, right? So elements are the basic substances, but they're made up of atoms, and atoms is the smallest unit of that element. So these atoms have protons, neutrons, and electrons, right? And they're positively charged or negatively charged or no charge at all. So part of these atoms, right? This is how they make up the elements here and how they figure out what their atomic number is. So atoms have 3 main parts, like we said, the protons, the neutrons, and electrons. Protons and neutrons are packed together tightly to form a dense core. Or a nucleus at the center of the atom. Electrons move about this nucleus on orbiting paths or shells at nearly the speed of light. So they're moving pretty fast. Protons are positively charged. And identify the atom for an example as a hydrogen atom or an oxygen atom, or etc. Neutrons have no charge whatsoever, no electrical charge. This determines the weight of the atom. How heavy is it? And electrons have a negative electrical charge. Under certain circumstances, they make it possible for the atoms to unite with others to form bonds. So hydrogen is the most simple. It has 1 positive proton and 1 negative electron. Hydrogen is number 1. Okay. Carbon is number 6. It has 6 neutral electrons, 6 negative electrons, and 6 positive protons. So they kind of all circle around each other. When you get up to like sulfur, it has the most. It's like
Miss Connie, I can't hear anything that you're saying. You sound like a robot right now on my computer.
Here we go. Here's our hair. Here's our structures. There's so that make up.
You're breaking up.
What this is showing you is, I don't know what to do about that. Turn my volume up. Did that help if I turn my volume up?
It's better right now.
Okay, I'll try to be closer. You can see my big old face in there. So this structure right here, this diagram, these are the atoms that make up the element that make up hair. So remember, hydrogen is the most
It's not working, Miss Connie. Are you there?
Okay. When you get to sulfur, it has more, but hydrogen, it makes a difference. So can you see me?
Can you guys hear her, or is it just my computer?
No, this happens all the time.
Oh, I can hear her. I can't even hear her anymore.
She probably bounced out the class and then she's gonna come back in and retry it in a second.
Is this any better?
Yes.
Okay. Trying something different here. Let me know if it changes. Okay, so this diagram right here, these are the atoms that make up the
Share your
element.
screen.
Oh, that would help, huh? Okay, let me get back to that. All right, better?
Perfect.
Okay, so these are the atoms that make up the elements that make up our hair. If you notice, hydrogen is the most basic one, right? There's one proton, one electron, right? So hydrogen is number one. So number one on this scale. So the numbers indicate how many protons are in a single atom of a particular element. So when we get to sulfur, there's
You're breaking up again, Miss Connie.
16. So that's why when we're working on making okay, is that any better?
I think it's just gonna keep cutting out on you like it always does, Miss Connie. I think the internet connection over there is not doing too well today.
I hooked up to my hotspot. So hopefully this will work. Let me make sure I'm still connected. Yeah, so I hooked up to my hotspot. So if it still is bad, then I don't know, it's probably Zoom. I'll plug this in.
Connie blank one.
I have no idea, Jane. What did I go back to? I keep getting kicked off of Zoom. They can't hear me.
Oh, crap. Don't say that.
They can't hear. I keep saying, is that any better?
Use your headphone.
Maybe.
Yeah, it's good for right now.
Yeah, that's better right now.
Sound kind of
Wonky there.
robot-y too to me. Okay. Okay, let's try this one. Okay, let's try this. Can you hear me now? Okay. So. Okay. Okay, good. Let's try that. All right, so we have hydrogen. This is the simplest atomic structure. One proton, one electron. Okay, chemical behavior of the atoms depends on the number of electrons in the outer shell. It can either be stable or unstable. If your electrons are missing in the outer shell or not missing, makes the difference between whether it's stable or unstable. So a stable atom is going to depend on the number of electrons orbiting the shell. And it is also, some atoms by their very structure are not missing any electrons in the outer shell, and they're considered stable or neutral. An unstable atom is missing electrons. The atom is considered unstable or reactive. Unstable atoms seek other atoms which they can share electrons to complete their outer shell. When they combine, they make molecules. Okay, so the size of the molecule makes a difference on how that product is going to penetrate into your skin or on how that product is going to penetrate into your hair, is the size of that molecule. So this is all, chemistry stuff. If you want to actually make products, we need to know how these things work. So you have an element, which is the simplest form of a structure. You have an atom, which makes up these elements. And when these atoms combine, they're known, or when these elements combine, they're known as molecules. Okay, so this makes up, the atoms make up molecules, which make up elements, which, yeah. So a molecule is two or more atoms joined together by a chemical bond. Right, so when the unstable atoms form, they become molecules, which are joined together by a chemical bond. Okay, so here's an example. Two hydrogen atoms form with one oxygen atom, and you get water. Another example would be ammonia. Ammonia is a compound. It's composed of nitrogen and hydrogen. Okay, we use ammonia. We use ammonia in perm solutions. We use it in color because it allows penetration to the hair strand. You gotta have ammonia and hydrogen peroxide to color hair. Okay. So in molecules, you can have pure substances or you can have mixtures. So with an element, atoms are the same. With a compound, the atoms are different. Okay, so pure substances, they're going to be things like gold, salt. What's another pure substance, Janie?
Pure gold.
Gold. How about aluminum? Is aluminum pure or is it mixed together?
Platinum. I don't know.
Platinum. She's all gold, diamonds, platinum. Guess where her mind's at. What about aluminum though? Is aluminum a mixture?
Yeah, I think it is because it makes it lighter, right?
Aluminum foil?
I don't know, yeah. Does it say aluminum is solid?
No, but I remember seeing that on a no,
Test question?
a test question. Is it a substance or is it a mixture? Is it a pure substance or is it a compound?
I
Aluminum
know.
foil.
Compound.
It's what?
It's a compound.
I think it's a
It's a
compound.
mixture. It's
Yeah.
not an element.
I don't think aluminum's an element. Yeah, I agree. I don't think it is either. I think it's made.
Copper is an element.
Okay. I'm trying to stun Miss Janie because she knows
Solid,
everything.
like, right?
No.
Completely fit, you know,
Oh, of course it's a solid. It's
but I mean,
foil. But
so it wasn't,
is it a pure or a mixture? That
Yeah,
was the thing I
that's
wanted to know. Compound or pure?
alright.
That's what I was wondering. Okay, so those are the differences that you're going to have to know with these, which is a pure substance. There's not very many. Let's see, what does it say out there? Pure substance. Okay, mixture. Mixture could be oil and water, right? Sand, things like that that are mixed together. Okay, so when these bonds combine chemically, they create compounds that create the protein of hair, right? Now, do we remember what our hair protein is called?
Keratin.
Yes. Yeah. Amino acids are the building blocks of protein. That's what amino acids are. They consist of carbon, oxygen, hydrogen, and nitrogen, and it's protein. So what this is showing you right here is this is the structure of the different hydrogens and nitrogens and carbons and hydrogen, nitrogen, carbon, oxygen, sulfur. And this is what makes up our hair. This is like the chain, the peptide chain there of the amino acids that make up our hair. So when they talk about the stable atoms and the unstable atoms and how they are attracted to each other and how they mix together, you will see that it starts with just an amino end of hydrogen and nitrogen. It combines with your carbon. The carbon then will combine with the oxygen, which combines back again with the hydrogen, and then we get the nitrogen, and then all of a sudden we have a piece of hair because they just keep combining and building and building and building all together. And these chains form together to become proteins. They intertwine and they wind up. If you kind of think about like a wire, you know, how all the wires kind of inside of a plug, inside of a cord, how they're kind of all like twisted around together. This is kind of how our hair forms together in these chains to become these different proteins. So hair is 97% keratin and 3% trace minerals, and it contains 19 amino acids. I believe sheep's wool is one of the closest to human hair at, I want to say 20, for some reason 21 pops in my mind amino acids, but hair contains 19. Our hair is known as a soft keratin, where our nails are known as hard keratin, and birds' beaks and rhinoceroses' horns are made out of the same type of keratin as our nails. So just a little like useless trivia knowledge there. So our hair gets connected by these peptide bonds or end bonds that put them together, and they're like the backbone, or they just kind of like hold it all together. It's like the glue that holds the stuff together and makes it strong. These chains link end to end. What you don't want to do is mess up that end bond. Okay, so we want to keep that hair strong. We want to keep those bonds together. So excessive chemicals, excessive heat, brushing your hair when it's wet, anything that could stretch that hair out and damage it is something that we do not want to do, because if we disturb them, then our hair gets damaged. Those are end bonds. We have side bonds now. these side bonds here, these are the ones that give our hair, what do I want to say? They're linked together. They have different services, different purposes in building the hair. So the hydrogen bond. The hydrogen bond is the bond that breaks down with water. This is the bond that we use when we style our hair every day. This is why when we get our hair wet, it changes. This is why if we put heat to our hair, it changes. It's also why when you wake up, you know, if you sweat at night, your hair's sticking up all over the place because it's the hydrogen bond that it works under. Easily broken with water or heat. Remember that for a test. Hydrogen bonds are easily broken with water or heat. It's not going to break your hair. It's just the bond that is broken down there that gives the hair its shape. So 35% of your hair strength is due to the hydrogen bonds. And I remember those types of questions being on a test at one point in time. Okay. The salt bond is the result of attraction of unlike charges. The negative charge in one amino acid attaches to the positive charge. Okay, so the salt bond helps organize the protein chains. Okay. The salt bond occurs for 35% of the hair's resistance to change. So if your hair's resistant, it is your salt bond that's working on that. So like hydrogen bonds, salt bonds aren't particularly strong. They're out there though. So since both hydrogen and salt bonds can be weakened with water, hair can be shampooed and blow dried into a new state or curled into a new state. When hair is saturated with water, the hydrogen and the salt bonds leave the hair more pliable, more easy to work with. Okay, so this is why when you style it and you dry it with like a round brush or something, the hydrogen and the salt bonds are what takes the shape of the style that you're trying to do. But it's only temporary because exposure to water will break these bonds again, or heat or humidity. Okay, so using a blow dryer and a brush is referred to as a physical change, since only the physical characteristics of your hair are changed, not the chemical ones. Okay, so this is the side that's probably one of the most important ones to any chemical services that you're going to be doing as far as straightening and perming goes. These sulfur chains join with other sulfur chains. And they form the disulfide bond. Okay, so this is the bond that forms between the protein structures. A lot of your chemical services, perming and relaxing, directly affect these disulfide bonds, either breaking the disulfide bond or reforming it in a new shape versus perming or relaxing. This process is a chemical change and produces the lasting results until it grows out, right? Then there's another one on here called van der Waals forces. It's based on theory that atomic groups prefer an environment with other groups that have structures similar to theirs. Okay, this bond, it's not important for us to know about, but we just have to know that it's there. It's not going to mess with any type of work that you're trying to do on someone's hair. You just need to know that it exists and it plays a role in bonding all of the protein chains together. Okay. So that's your van der Waals forces, just know they're there. Okay, so there's our hydrogen bonds again. Works on principle, can be easily broken by heat or water, and accounts for 35% of hair's strength. That's what you need to know about the hydrogen bonds. We go to the salt bonds. Negative charge accounts for 35% of the hair's resistance to change. Sulfide bond results when sulfur type side chains join with other sulfur type side chains. Most important bond to barbers. Bond or reformed by chemical services producing chemical changes until it grows out, with lasting results. You gotta grow out or be cut off. And then van der Waals forces, based on a theory that atomic groups prefer the environment with other groups. Not important for barbering services other than to know that they exist. Okay, let's see, I'm down here at the bottom. Julian, you with us? Anything that occupies space and has weight is matter, true or false?
Wait, is this question on me?
Yeah.
Which one am I?
One.
Oh, okay. True or false? Anything that occupies? True.
Okay, Ruben. Atoms have a nucleus containing protons and electrons.
That's true, but they also have neutrons. Oh wait,
So,
atoms have a nucleus containing. Oh no, the nucleus is just protons, isn't it? So it's false.
okay. And Nick, 3. Chemical behavior of atoms depends mostly on the number of electrons in the
I don't know. I'm just gonna guess and say cell membrane.
okay. Okay. Who's after that? Hillary. With an element, the atoms are the same. With a compound, the atoms are
Different.
Dulce. The bond formed when an acid end of an amino acid attaches to the amino end of another is called.
Is that a manicure class starter? By any chance?
Could be
Okay.
keratin.
The keratin, yeah, that's what the hair is made out of. Okay, go back to Julian. Julian, number 6 is yours. Let's see.
Hello. I can't even hear you.
Number 6, the bond formed when a hydrogen atom in one molecule attracts an atom of another molecule with negative electrons. What type of bond is that?
Chemical bond.
Okay. Who's next? Ruben, number 7. When a negative charge in one amino acid grouping attracts the positive charge in another form, it's called a what? These are hard. This means you know, see what you need to study.
And,
I don't know that one.
Okay, what's the next one? Hair has many hydrogen bonds. Nick, hair has many.
Ahí dejé una tarjeta. ¿No la agarraste?
You got that one, Nick?
Hold on.
Hair has many hydrogen bonds, which are individually very weak and can be easily broken by heat or, oh, that one's not hard. Hydrogen, what breaks the hydrogen bond? Heat or what?
I don't know that one.
Okay. Hillary, the most important bond to the barber's work is?
I don't know that one.
Okay.
Could be a hydrogen.
Which one?
Side bond? Is it side bond? No.
It's one of the, no, it's not a side bond. It's one of the bonds that makes a pair. Wait, it is a type of a side bond. Sorry, I was wrong.
It's James Bond.
James bond, yes. When the sulfur type chains join with other sulfur type side chains, they form the okay. So this is what we're going to need to know and more for this test. So anything that occupies space and has weight is matter. That's true. Ruben, you did that great little deduction there about atoms having a nucleus containing protons, electrons. The nucleus is made up of the protons and the neutrons, but you've got neutrons in there. So you did that great little analogy there. Chemical behavior of atoms depends mostly on the number of electrons in the outer shell. We have the atoms are the same with a compound, the atoms are different. The bond formed when an acid end of an amino acid attaches to the amino end of another, it's called a peptide bond. Peptide chains are what make up our hair. The bond formed when a hydrogen atom in one molecule attracts to an atom of another molecule with negative electrons. It's called a hydrogen bond. When a negative one amino acid being attracts the positive charge in another form, it's called a salt bond. And then hair has many hydrogen bonds, which are individually very weak and can easily be broken by heat or water. And the disulfide bond, that's considered to be the most important, and it's also a sulfur type chain. So there's a lot of things in just this one little section here that you kind of need to know about, especially if you're going to be doing any type of chemical services, because these are the things that we have to understand how it works in order for water to work with our hair, and how to style, how to do chemicals, how it's going to react. Sometimes why product works on one certain type of hair really well, but it doesn't work on another type of hair. All of this comes down to it. So in the back of this, if you want to study, review these matter things in the back of your book, and you'll be able to help yourself out with that one. All right, so now let me get back to pH scale. This is another thing. pH scale starts with water. Okay, this is something that is definitely important to understand, how your hair is made, how your hair works, and then what the pH scale has to do with how these products work on your hair. Especially going into doing chemical services. But just understanding how a gel works on your hair, or how a wax works on your hair, something like that. It makes a big difference. Donna, hey, Miss B was looking for the manicuring test. I don't know where they are. In Linda's locker, probably one of those binders that we found the other stuff. Anyone know what pH stands for? What actual pH stands for? It stands for potential hydrogen. Yeah, and it all has to do with water, right? Our world revolves around water. Everything we do revolves around water so much. Okay, so why do you need to know about the pH scale? Because you need to know what you're going to be using and how it works. Now you got those little test strips, right? Anyone tested anything yet with your homework? You got a few?
yeah.
You did? What'd you test?
No, yeah, just the one we did on classroom, the lotion, yeah.
Yeah, okay. So we're going to understand how this works and how it has to work with our hair. Frizzy, out of control hair, dull hair, limp looking hair could be all has to do with the pH scale. Okay, so it starts with water. Potential hydrogen is what it means. It is a measurement, a numerical, so it has to do with numbers, right? So it indicates the acidity or the alkalinity of a water-based solution. Okay, things that we use on us most of the time are water-based. It has to be a water base in order for us to absorb most of it. So most of the things, a lot of things that we use are all water-based. So why do they have different pH values? Well, it starts with your water. Do you think all water tastes the same? I don't. I sure don't. Okay, so water molecules, water, H2O, right? 2 hydrogen, 1 oxygen. So they can split, creating an hydroxy ion, which is negative, or a positive hydrogen ion, which is positive. Okay, when the water splits. So see, it all starts with this whole elements of water. So pure water, distilled water, it's considered neutral because the ions there being positive and negative, they balance each other out, and that's how it becomes neutral. They don't have more positive or they don't have more negative ions in there. So that's how it totally balances each other out. Were they there?
Some.
I think they were just making them as they go
But where were they making them?
on Knowledge Builder.
Cosmetology. Manicure.
No. Okay, so acids and alkalis make the difference, right? Acid is for 7 and below, and alkalis are going to be, or sometimes are known as base or alkaline, which is going to be above 7. So what happens is an acid substance donates or releases the positive ions. Okay, so if it's more acidic, it has more positive hydrogen ions than negative hydroxy ions. And you're gonna need to know the difference between the positive and the negative because of the test. Okay, if it's an alkaline, it decreases the concentration of hydrogen because the water accepts it or it combines with that. So what do you need to know? You need to know if it's an alkaline, it has a decrease in hydrogen ions when placed in water. So you're going to see like oxygen, hydrogen, hydroxys, acids, alkalis, bases. These are all terms you're going to have to know what they mean. Okay, if you know what these terms mean, even if you don't understand the question, you may be able to figure out if it's a positive or a negative. So an alkaline solution has more negative hydroxy ions. So we have our pH scale here. Okay, it goes from 0 to 7, with 7 is being neutral. Numbers less than 7 have more acidity. Numbers more than 7 have more alkalinity. This is known as a logarithm. So it's a logarithmic scale. What it means is each change in value along the way changes 10 times. So if 7 is being neutral, 8 is 10 times stronger than 7. So then we go to 9. So 10 times 10 is 100. So 9 is a 10 or 100 times stronger. Then you go to 10, right? So 10 times 100 is 1,000. So, or 10, yeah, that's 1,000. Then it goes to like 10,000. So each one of those goes up by 10 as being stronger. So this is why some of the things on this pH scale make a huge difference. If we look up the pH of, say, an orange or a lemon, they're very acidic, right? We're looking over at a 2 and a 3 on the pH scale, where our hair, skin, and nails is a 4.5 to a 5.5. If we're looking at things like perm solutions, chemical relaxers, we're over here between like hair bleaches, hair color, any chemicals that we may be using on the hair, we're at like a 10 point something all the way up to like a 14, depending on how strong they are. If we're looking things like soaps that we used to take a bath with, the strongest one I've ever seen is Irish Spring, and that's like a 12. Zest is there at like a 10. Dove is like a 9, 8 or a 9. We've got blood and urine, which hit between like 8 and 10, depending on, you know, your body, your blood and your urine in there. Battery acid would be over there like on a 0. But some things that you have to think about with the pH scale is they have an organic, just like, you know, organic chemistry. And then there's the inorganic. So we're really not going to be putting things on our skin that come from the inorganic side. Like we would never put battery acid on our skin, but we squeeze lemons and oranges and stuff all the time. You know, we eat those. So we get that type of acid on our skin. So in facials, there's a lot of acids that people use, like acid peels, and they use it from, they have one called glycolic acid that comes from sugarcane. And that one can be down to like, what is it? We cannot purchase anything lower than a 3 being licensed. But if you go to a doctor, they may use something like phenol acid, which would be, you know, even lower. So it really makes a difference on the products, on what you know on the pH scale. And then with the acids, they have beta acids and hydroxy acids and alpha hydroxy acids. And yeah, that's a whole nother category over there. But they do have a lot of those that we use. So measuring the pH, we gave you guys the indicator papers, thoughts for you to play with. They have indicator liquids. This is more like something that you would use for like maybe a pool. You know, if you're trying to check the pH of your pool, a meter, just kind of stick it in there and it'll read it itself. Now they used to have these things called, like they were pens, and they would peel the thing off and you could just like color it and it would tell you the pH on that. So they have a lot of different ways, but usually the indicator papers, liquids, or meters are what's the most popular today. The papers are known as litmus papers. The pH or the nitrazine paper also can provide a specific number, but it changes color, right? The liquid changes color with the drops that you put in there. The meter, that's the most accurate, but of course it's probably a little bit more expensive than a piece of paper. So if you come out with something saying that it's pH balanced to your hair, skin, and nails means that when you test that, it should come between a 4.5 and a 5.5. Okay, so that's what skin is. Most products that you use will be between a 4.5 and a 5.5. So just to give you a little example of some things that we're using, shaving cream is probably a 5.5 to a 6.5 because it does have a little bit of a cleansing property to it. An aftershave could be a 5.5 to a 7. Shampoos and conditioners, depending on which type of shampoo you have, you're looking at a 3.5 all the way up to a 9.0. Perms and relaxers, depending on if they're an acid perm or an alkaline perm, you're looking at anywhere from a 6.9 to 14. Colors and bleaches, you're looking at anywhere between a, what does this say, 8.0 to 11. Hair products like mousses and styling pastes and gels and pomade, they're all running between a 5 to a 7.9. 7.9 would be something like a paste or a spiking gel because it's going to be a little bit harder. Okay, and then if we're looking at the skin products, we're probably going anywhere from a cleanser, toner, or moisturizer from a 4.5 to a 6.0, just depending on what we're looking at for the actual skin. And all of this is going to make a difference how it reacts on your hair, or your skin, depending on if your skin's more dry or more oily, or if your hair is more dry or more oily, or more coarse or more fine. All of that is going to play a difference on how these products work. Okay, Dulce. pH is a numerical measurement that indicates the acidity or alkalinity of a water-based solution.
Are you sharing by your screen or
Yeah, says
I
it should be. Can't see it?
no?
Oh, okay. Let me try this again then, because it said it was being shared. Can you see it now?
Yeah.
Okay. So remember, the pH scale indicates whether the substance is acidic, neutral, or alkaline. So if it's saying it's a pH is a numerical measurement that indicates the acidity or alkalinity of a water-based substance.
True.
True, okay. So acids and alkalis are substances that change the balance of hydrogen peroxide of ions in water. So who's next? Hillary. Pure water has more positive than ions. Is that true or false? Pure water has more positive than negative.
True.
Keyword is pure. It's pure. That's the keyword. Okay, who's next up? Nick. A substance that increases the concentration of hydrogen ions when placed in water is.
I don't know.
Increases the hydrogen ions, right? So it's either going to be acid or alkaline. One or the other, acids or alkalines. So if we have a acid is a substance that increases the concentration of hydrogen ions when placed in water because it releases the positive hydrogen. Okay. A substance that decreases as an alkaline because you lose the hydrogen positive ions and you are replaced with hydroxy ions, which is known as the OH.
So it's acid. So it's acid then?
Yeah, the 3 is acid and 4 would be alkali. Okay. So 5, who's after Nick on here? Julian. pH scale ranges from what? What are the numbers on the pH scale? 0 to what? Julian, that one's yours.
I forgot what the last one was.
pH scale ranges from 0 to
4?
I think
14.
it's from 0 to 14.
It's 14, yeah. 14 is the
14.
highest number on the pH scale. Definitely. Okay, so the pH value of 7 is what, Ruben? Would it be acid, would it be neutral, or would it be alkaline?
Neutral.
Right. So Dulce, then if we go back to below 7, which one is that? 7 is neutral, below 7, 0 to 7 is what?
It could be acid or
Yes. So Hillary, if we go above 7, what do we have?
Alkaline.
Yeah. And then Nick, logarithmic means that the change in value along the pH scale is a change of how many more times is 8?
Oh, okay.
What do you times it by each time?
10.
Right. 10 times, yes. And then Julian, A product with the pH value of 4.5 to 5.5 is considered to be what?
I don't know.
Okay, what are our hair, skin, and nails? Our hair, skin, and nails is
Just
a
below me.
4.5 to a 5.5. So if it's pH balanced, it's pH balanced, 4.5 to 5.5.
Yeah.
So, seawater. Now here's something that's kind of interesting because we have pure distilled water at a 7, right? Pure water. Seawater is considered to be an 8, right? Hand soap, bleach, ammonia lye, they're all like 12 to 14. Milk is a 6.5. Your stomach acids are a 1.5 to a 2.0. So there's a couple little things for you there that might be kind of interesting. Okay, so there's more questions here. True, false, acid. So pure
Yeah.
water has equal charges. There's not more positive than there is negative. Acid, 0 to 14. Acidity, alkalinity, 10 times, and balance. Okay, so there you go. There's this portion for you. Tomorrow, we're gonna go over the hair care knowledge and cosmetic classifications. So, all right, you guys, get your homework, turn it in, okay? All right, I will see you guys tomorrow. Have a great day. Anyone have any questions? No questions?
No.
Okay, oh yeah, FYI, if you're working on your books, remember how I said like you have 45 minutes before it's gonna kick you off? So go back in and all you have to do is hit the refresh button. I found that out yesterday. You just hit the refresh button. That's all you have to do and it keeps your time accumulating while you're working on your smart notes. Okay? Okay. See you guys tomorrow.